Imagine walking onto like a traditional 20th century factory floor. You've got your floor managers, the assembly line workers, and raw materials physically moving from station to station.
Right, the classic industrial setup.
Exactly. And every single step of that process is fundamentally bottlenecked by human bandwidth. I mean, a person has to physically pull a lever or, check a pressure gauge or sign off on a clipboard before the next stage can even start.
Yeah, it's a reliable system, but it's inherently throttled. I mean, the speed of production is literally capped by human reaction time and, well, physical stamina and just the manual transfer of information.
Right. So now imagine you walk onto that exact same factory floor tomorrow, only the assembly line isn't waiting for a person anymore.
Oh, yeah.
Instead, you have this invisible, highly interconnected workforce of like hundreds of specialized digital agents, and they're constantly communicating with each other, spotting defects in real time, recalibrating machines, just managing the entire production line autonomously.
And the human managers are nowhere near the levers.
Exactly. They're standing on a catwalk high above, just orchestrating the entire system.
And that is the exact transition happening in enterprise software today. We are moving entirely away from this old paradigm of isolated intelligence, like a chatbot sitting in a separate browser window just waiting for a prompt.
Yeah.
We're officially entering the era of multi-agent orchestration.
Okay, let's unpack this. Because if you are a non-technical executive trying to navigate this landscape, the conversation is, it's no longer about whether AI works. You know it works.
Right, that debate is over.
The question now is how you operationalize it, how you scale it, and crucially, how you govern it responsibly. Because we are looking at a massive industry-wide shift where AI is becoming the actual core operational infrastructure of modern business.
Yeah, and to understand the sheer velocity of this shift, you really just have to follow the enterprise budgets. We are decisively out of the AI hype cycle.
Oh, absolutely. The honeymoon phase is over.
Exactly. The novelty of conversational toys and parlor tricks, that's worn off. Today, companies are demanding quantifiable, measurable returns on investment.
Which brings us to our first source for this deep dive, a company called Glean. So they build enterprise search and knowledge retrieval platforms, and they just crossed $300 million in annualized revenue.
Which is just a staggering number.
Right. That number is a massive signal. You do not hit $300 million by selling a neat gimmick. You hit that by solving an incredibly expensive problem.
And the expensive problem they are solving is organizational friction. Think about a typical enterprise environment today. You have proprietary data siloed across thousands of emails, endless Slack channels, complex CRMs, legacy cloud storage.
Just a total mess.
Right, a total nightmare. And web search is relatively easy because public websites link to each other. But enterprise search is notoriously difficult because of complex permission structures and just fragmented data lakes.
Yeah, you can't just Google your own company's internal payroll policies from 3 years ago.
Exactly. So Glean's explosive revenue growth proves that companies are redirecting their budgets. They're moving away from these experimental innovation funds and deploying capital strictly to compress that operational overhead.
They are essentially buying back thousands of hours of wasted employee time. So the metric for ROI has totally shifted from, look at this cool new capability to look at how much operational drag we just eliminated.
Precisely.
And that enterprise demand for reliability is completely changing how the foundational AI models are even being built. Look at Anthropic's recent release of Claude Opus 4.8.
Yeah, a massive pivot there.
Right. They are no longer leading their pitch with raw intelligence benchmarks. They aren't bragging about passing the bar exam or crushing the SATs anymore.
Because passing a theoretical exam does not translate to actual enterprise value. Anthropic's strategic pivot is it's entirely focused on runtime reliability, uncertainty recognition, and error detection.
Okay, wait. Walk me through the mechanics of that. What does uncertainty recognition actually look like in practice for a business workflow?
Okay, so let's say you ask a standard early generation model to pull quarterly financial data across 3 different international divisions, right? And you want it to forecast a trend.
Sure. Standard executive request.
Right. An older model, driven by the need to just be helpful, might hallucinate missing data just to give you a complete, confident-sounding answer.
Which is terrifying.
It is. That false confidence is toxic. A single hallucinated metric in a supply chain forecast can cost millions of dollars. So uncertainty recognition means the model is architected to actually pause, analyze its own context window, and flag gaps.
Oh, wow. So it pushes back.
Exactly. It operates with a built-in mechanism that basically says, I have 80% of the data needed for this forecast, but the Q3 figures for the European division are ambiguous. I need human clarification before I proceed.
I love this. It's like we're transitioning from hiring a brilliant but erratic intern who just guesses when they don't know the answer
Yeah.
to hiring a seasoned manager whose biggest flex is basically saying, I don't know, let me verify that.
That is a perfect analogy. For executives, that reliability is the real ROI.
Yeah.
It is all about building operational trust. If you're deploying an AI to manage long-horizon workflows tasks that unfold over several days, needing constant retrieval and validation, its ability to self-audit matters way more than its raw IQ.
So if the industry is pivoting to that level of reliability,
Mm,
how does it change the actual deployment? Because the way we interface with AI is fundamentally shifting too.
yeah,
We're moving away from the single agent chat window,
yeah.
right? And we're watching these systems basically take over the software environment itself.
Oh, absolutely. We are entering the era of the enterprise operating layer. Take Anthropic's introduction of dynamic workflows in Claude Code. They have moved entirely past sequential execution.
Meaning instead of one AI trying to do everything step by step,
Yeah.
it can spawn multiple sub-agents.
Exactly. Think about how a highly functional human team operates. You don't have one person doing the deep research, drafting the legal compliance report, and writing the software code all at the exact same time.
No, you delegate.
You delegate. And these new systems operate using distributed cognition. A primary agent gets a complex objective from a user, and it instantly spawns specialized sub-agents to tackle different facets of the problem simultaneously.
And then it just brings it all together.
Right. It synthesizes their outputs into a final product.
And this is bleeding out of software development directly into general enterprise tools, isn't it? Like Microsoft has completely redesigned their 365 Copilot, and Perplexity has introduced that deeply integrated computer function.
Yes. The AI is no longer a sidebar assistant you occasionally ask a question to. It is operating natively inside Word, Excel, Teams, and Outlook.
It's just wild.
It really is. It's navigating the digital environment using the same context a human employee would use. It can read a live spreadsheet, cross-reference those numbers with an ongoing email thread in Outlook, and autonomously draft a presentation in PowerPoint.
Okay, let me push back on this for a second, because this is where I get hung up. If the AI is jumping between applications, acting like a digital employee, and handling these multifaceted workflows autonomously, how does a non-technical executive actually supervise that?
That is the million-dollar question.
Right, because you cannot manage an AI the way you manage a human analyst. The speed and scale are just totally different. Doesn't this force a complete reframing of what leadership even means?
What's fascinating here is that it forces a massive reframing. We are shifting from an app-centric management style to a context-centric one.
Could define that. What does context-centric mean here?
Historically, your job as a manager was to assign specific tasks within specific apps, like go into Excel and run this pivot table, or go into Outlook and draft this client update.
Very micromanagerial.
Exactly. Now, your job is to manage the outcomes of coordinated agent teams. You define the strategic objective, you provide the rich business context and the guardrails, and you let the multi-agent system orchestrate the granular execution across the software stack.
Got it. So you are managing the orchestra, not playing the instruments.
Exactly.
But to see the real-world friction of this executive reframe, we have to look at the department where this transition is happening the fastest and, honestly, the most expensively.
Software engineering.
Yes, software engineering. So Cognition, the company behind the Devon AI coding agent, recently raised $1 billion at a reported $25 billion valuation.
Yeah, that valuation is a massive bet by the market that software engineering is permanently transitioning to AI-managed execution pipelines. Investors aren't valuing a standalone tool, they're valuing a completely new paradigm of digital production.
But there is a serious hidden cost to this paradigm, right? GitHub recently shifted their Copilot tool to token-based billing, and it caused a massive backlash from developers. I want to dig into the mechanics of this because it feels crucial. Why is token-based billing suddenly such a big deal? Why does an autonomous agent burn through so much more compute power than the AI tools we were using just like a year ago?
It really comes down to the fundamental difference between autocomplete and autonomous self-correction.
Okay.
When AI was just predicting the next line of code, it ran one quick query. It cost a fraction of a cent. But an autonomous agent like Devon doesn't just write a line of code. It reads an entire massive code base, identifies an architecture flaw, attempts to write a fix, runs a test suite, fails the test, reads the error log, adjusts its approach, and runs the test again.
Wow, so just looping constantly.
Exactly. It might cycle through that self-correction loop hundreds of times in the background before it ever presents a successful result to a human.
So every single one of those background loops is consuming tokens. It's chewing up massive amounts of server compute while you're just sitting there waiting for the fix.
Yes. And that completely alters the economics of AI for a business. We are moving from a predictable software as a service model where you pay a flat $30 a month per seat to an infrastructure consumption model.
Like paying for electricity.
Exactly. It's like turning on a fire hose of cloud compute. If leaders aren't actively governing how these agents use tokens, their operational costs will absolutely explode.
The economics are definitely tricky, but what about the human element? Because developers are reportedly refusing to work without AI now. It is so embedded for writing boilerplate code and debugging that they basically consider it indispensable.
They do. It's a dependency now.
But if we lean entirely on these multi-agent systems to build our software, are we setting a trap for ourselves? Here's where it gets really interesting. Let me use an aviation analogy. It feels like we are transitioning to fly-by-wire commercial jets.
Oh, I see where you're going with this.
Right. The pilot isn't physically moving the flaps with a mechanical yoke anymore. They're inputting their intent into a computer, and the computer makes thousands of micro-adjustments to fly the plane. But if the sensors fail, the pilot still needs to know how to fly the plane manually. If an AI builds our entire enterprise architecture and it crashes, who fixes it if the humans don't actually understand the code?
That is arguably the most critical risk in the industry right now. It is a phenomenon known as technical depth erosion.
Technical depth erosion.
Yeah. When you offload the heavy lifting of system architecture to an AI, the human engineers literally lose the muscle memory of how the underlying foundation actually works. The hidden complexity of AI-generated infrastructure becomes a massive operational liability.
So how do you prevent that? How does a non-technical leader ensure their engineering team doesn't forget how to fly the plane?
You have to intentionally build a culture of operational trust that balances AI acceleration with strict verification discipline.
Meaning what, exactly?
Meaning mandating that engineers do not just accept AI outputs blindly. They must systematically audit the AI's logic. The most valuable skill for an engineer moving forward isn't writing code quickly. It is the system-level reasoning required to verify, audit, and untangle complex AI-generated environments.
You need humans who deeply understand the physics of the factory floor, even if the robots are doing the actual welding.
Perfectly said.
And this orchestration model isn't just happening with code and spreadsheets. It is completely industrializing creativity, marketing, media production, audio. It's all becoming an automated pipeline because these multimodal agents can now collaborate.
Oh, the multimodal stuff is mind-blowing.
Let's look at what's happening in marketing with tools like Ads Creator AI. Instead of a human team brainstorming copy, sending it to a graphic designer, and then having a media buyer run manual A/B tests, the AI is running that entire feedback loop autonomously.
Right, in a 5-step cycle.
Exactly, a 5-step cycle. First, it generates the copy. 2, it creates the visual assets. 3, it deploys dozens of campaign variations across social platforms. 4, it monitors the engagement metrics in real time. And 5, it optimizes the performance on the fly based on what is actually converting.
It's a continuous loop of AI-mediated creative systems. And the reason this continuous automated loop is now possible is because the underlying architecture has fundamentally changed. A major catalyst here is MCP, or the Model Context Protocol. Runway, a major player in AI video generation, recently adopted it.
Break that down for me. What does the Model Context Protocol actually do under the hood to make this interoperability possible?
Think of MCP as a universal translator and a highly secure pathway for AI agents.
Okay.
Historically, if you wanted an AI to analyze your company's proprietary data and then generate a video based on it, your engineering team had to build custom, fragile API connections. It took months of development.
Super tedious.
Very. But MCP standardizes that integration layer. It allows different AI models to securely connect to diverse enterprise data sources, whether that's a local database, a GitHub repository, or a live marketing dashboard, without needing a human to handhold the data transfer.
So an AI marketing agent running a campaign can autonomously use MCP to securely ping a video generation agent like Runway, feed it the necessary brand context and performance data, and have it spit out a formatted video at all without a human ever touching a keyboard.
Precisely. And Microsoft is doing the exact same thing by embedding highly reliable image generation directly into their enterprise productivity tools with their MAI Image 2.5 model.
And the 11 Labs is pushing this into audio, right? With Dubbing Studio V2 and Music V2.
Yeah, they are preserving emotional voice context across languages and creating programmable commercial-grade music. The interoperability is the real breakthrough here.
Which drastically lowers the barrier to entry.
Yeah.
I mean, if you're a non-technical executive, you no longer need a massive agency budget, a dedicated localization team, and a studio composer to launch a global campaign. But you do need a completely different skill set. You have to know how to set the parameters, define the brain constraints, and basically direct this autonomous orchestra.
And as these autonomous orchestrations master the digital realm, coding, designing, analyzing, they are inevitably spilling over into the physical world.
The physical expansion is where the complexity really scales up. We are seeing embodied AI moving into retail and logistics. For example, the humanoid robotics company Figure recently partnered with Catalyst Brands to deploy agents into physical retail operations.
Which is wild to actually see in practice.
It is. But how does an AI, which is essentially just code and math, actually understand a chaotic physical environment like a retail stockroom?
The technological leap there is vision language models, or VLMs. Instead of just processing text, a VLM can ingest a real-time video feed and translate those 2D pixels into 3D spatial reasoning.
Oh, wow.
Yeah, it allows the embodied AI to look at a chaotic shelf, recognize that a specific product is out of stock despite changing lighting or displaced items, cross-reference that visual data with the inventory database, navigate the stockroom, and physically restock the item.
It is marrying the cognitive reasoning of a large language model with real-world spatial awareness.
Exactly.
That is incredible, but it also brings us to the darker side of this shift. Because as these systems become more autonomous and more deeply integrated into our daily operations, the risks naturally multiply. We are seeing a trend of organizations becoming what the sources call AI-pilled.
Yeah, AI-pilled. That is a term used to describe companies that adopt AI recklessly. They are so desperate to cut operational costs and increase velocity that they strip away all human review layers before establishing proper governance.
Right. They basically fire the co-pilot, turn on the autopilot, and go to sleep.
And the result is massive operational fragility. You get unintended over-automation, where agents are making cascading errors at the speed of light, all because no human is in the loop to catch the initial mistake.
And it goes beyond just operational errors. There's a deeply psychological cost to this. As we deploy persistent, highly human-like AI systems, we are seeing the emergence of what researchers are calling AI psychosis.
This is a really serious issue.
Walk me through the mechanics of that. Why is a conversational user interface suddenly a psychological risk for an enterprise?
Because humans are biologically wired to anthropomorphize things that talk to us. And these new models are incredibly fluent, emotionally resonant, and designed by default to be agreeable.
Right. They're programmed to be helpful.
Exactly. When employees or customers interact with a persistent AI agent on a daily basis, they can unintentionally develop deep emotional dependencies. The AI always listens, it never judges, and it always validates. For vulnerable individuals, this can reinforce delusional beliefs or amplify psychological fragilities because the AI lacks the true human judgment to establish healthy emotional boundaries.
It is essentially a superpowered yes man that never sleeps.
Yeah.
So how do you govern this? If the technology is this powerful and potentially this risky, what is the blueprint for a non-technical leader?
If we connect this to the bigger picture, you really need a logical 3-step plan to transition your organization safely. Step 1. Establish rigorous verification discipline.
Okay.
You must build human escalation frameworks where AI outputs are systematically audited. You do not blindly trust the system, you verify the logic.
Keep the pilots trained on how to manually fly the plane.
Step 2. Govern your compute economics. As we discussed with the token billing shock, autonomous agents consume massive infrastructure resources. You have to actively monitor your token usage and ensure the operational efficiency you're gaining actually justifies the heavy compute costs. Treat compute like a premium utility.
Right, you can't just leave the faucet running. And step 3.
Step 3. Manage the human-AI boundaries. You must establish strict behavioral alignment for any persistent AI interacting with your teams or your customers. You have to intentionally design friction or boundaries into the conversational UI to mitigate risks like emotional dependency. The winners in this new era won't be the companies that adopt AI the fastest. It will be the organizations that achieve true operational AI maturity.
We have covered a tremendous amount of ground today. To synthesize this for you, the era of testing AI chatbots is definitively over. We have entered the era of multi-agent infrastructure. AI is now a persistent, coordinated operating layer. To survive and thrive in this landscape, your job as a non-technical leader is to focus on workflow reliability, aggressively govern your compute economics, and fundamentally reframe your role. You are no longer a task manager. You are an orchestration overseer.
Execution quality and the strictness of your governance are your new competitive differentiators.
So what does this all mean for you as you head back to your own factory floor tomorrow?
Well, I want to leave you with one final lingering thought to mull over. If our enterprise software, our global marketing campaigns, and our physical logistics are entirely orchestrated by AI agents validating other AI agents, who ultimately audits the AI's moral and strategic judgment when a systemic failure happens at the speed of light. Because by the time a human manager up on that catwalk realizes the orchestra is playing the wrong song, the concert might already be over.